everyone, it's Mr. Canfield. Today we're doing 1-3, midpoint and distance, so let's get started. Our first activity is talking about Latanya, or Latanya. Latanya is decorating her living room and draws a floor plan to help look at placement. So boom, here's her floor plan. And the first question is, she wants to hang a picture at the center of the back wall. So the center of this back wall, how do you find the point at the center between A and B? So there's a few ways to think about this. One way to do it is to find out how long the wall is. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I got the wall was 11 long. Well, if I want to hang it in the middle, what's the middle of 11? Whatever 11 divided by 2 is, which is 5.5. So if I went 5.5 spaces, 1, 2, 3, 4, 5 spaces, and then halfway, that should be the exact halfway point. And if we go, here's the half space, and then 1, 2, 3, 4, 5, it finishes it. Yeah, so 5.5 spaces, boom, there's the center of the wall. So what if she wants to place a lamp halfway between the chairs at points C and D? So here's the chair C, here's the chair D. We're pretending that that is where the chair is, not the whole block. And we want to find the halfway point. So there's a couple of ways we could think about this. Let's see. We're trying to get from here to here, and we want to get the halfway point. But remember, if we kind of think about where does it look like halfway between, well, it looks like we're going down 2 blocks and over a block, and then down 2 blocks and over a block. So it really looks like that's the halfway point. So in this example, it's pretty nice. You can see where it is pretty evenly. Looks like we're at the point 10, 7. So we're going to generalize this, and we're going to be able to do it without being able to see the picture. So when we have the picture, it can be really helpful. But sometimes it's not so straightforward. So the midpoint, literally the point between, halfway between 2 other points. If we were looking at a line segment like we were last time, we would call this point as being the bisector. Remember, bisecting means that it cuts it in half of these 2 other points. So midpoint of PQ, this formula looks wild, but it's really, really, really simple. And the reason I say that is the formula literally means take the average of the x's and take the average of the y's. And the math word sometimes that you'll see for average is mean. So take the mean of the x's, take the mean of the y's. I want to remind you about a couple things about this formula, then we'll talk about how it works. So see these 1s and 2s. The 1s and 2s, when they're little subscripts like this is different than when you saw things like x with a 2 up here. This is called an exponent when it's like this, and that is not the situation that we're dealing with here. What we are dealing with is just a subscript that tells us x number 1 and x number 2. So the first x and the second x. So to find the midpoint between 2 points, you literally take the points and you go, okay, so I got 2, 1 and -4, -3. Okay, let me just write that down. 2, 1, -4, -3. And if I said, hey, find the average between 2 things, most people have picked up how to find the average at some point in their life. The way you find the average between 2 things is you add them up and divide by how many. And so in this case, we're only dealing with 2 things. So if I want to find the average between these 2 numbers, I add them up and divide by 2, because there's 2 of them. So I'd literally take 2 plus -4, and again, I say this every time, if you need your calculator, you need your calculator. Don't be ashamed about it, just know that you need it. So 2 plus -4, I don't know if this calculator actually does it. Yeah, no, okay, so this calculator doesn't do exactly what I want. Let me grab a calculator that I'm comfortable working with. Oh, hey, it's Maeve. Hi, Maeve. It's Mave and Mum and Mummy. Wait, Wabbit, where are you? I haven't. Oh. Hey, there we are. Okay. Hey, buddy. All right. So 2 plus -4, bam, -2, which I knew that already. I just wanted to show you that there's no shame in doing that. And then divide by 2. So -2 divided by 2. So -1 is going to be the first coordinate. This is just saying, hey, do the x coordinate, comma, do the y coordinate. So we'll do the y coordinate, 1 plus -3. And then we'll divide that whole thing by 2. So 1 plus -3 is also -2, divided by 2 is -1. If I was going to do this on my calculator completely, I might even do this. I might do parentheses, type the top of this in, 1 plus -3, close the parentheses, divide by 2. You can do that all in one step in your calculator. Boom, does it all for you. I'm fine if you do that. I don't care. This is not an arithmetic class. This is a geometry class where we're using arithmetic and other skills to solve geometry problems. So the goal is not for you to learn arithmetic this year. The goal is for you to learn geometry. That's why I'm fine with you using a calculator. So instead of having to count our way there, we were able to use that formula. And no matter where the two things are, always works the same way. All right, so find a midpoint and try it. So this is our first big formula that we learn. And all we have to do is take the x's and add them up, then divide by 2. Take the y's, add them up, divide by 2. So if I'm trying to find the midpoint, the point that's halfway between -3, 2 and 4, -2, all I have to do is add them up. And let's see what they say. Yep, see, that's all they're showing. They take -3 plus 4, which is 1, divided by 2 is a half. So it's all that's going on. So you can try these examples here. It's more of the same. So, oh, you know what? I think one thing worth mentioning here, 2 plus -2 is 0, and 0 divided by 2 is 0. So the midpoint actually happens at the y value 0 right there. Okay. So that's our first big idea today, and I'm trying to make this a briefer video. So if you missed something, feel free to go back or look in your notes or shoot me a question in the comments or email or anything like that. We're going to learn how we find the distance formula. This monstrosity. This is the distance formula. We're about to show where this comes from. Right now, it's probably really scary looking if you've never seen it before. It's got a huge square root, junk, squares, parentheses. So let's just let's talk about it simply first before you have to deal with how awful it looks. So I want to just show it to you and point a couple of things out, and you'll see how simple it can actually feel. So right now, if you've never seen this before, this looks really, really intimidating. So let's notice it's got both x's and a square. It's got both y's and a square. Can you notice something similar about both situations? It's second minus the first squared. Second minus the first squared. And what we do when we do the distance formula is we do all the insides, and then we just take the square root of it. And believe it or not, this formula is pretty easy to discover. But I wanted to show it to you first because of how messy it is. So I actually put these examples out of order so that we could just see it first before we dive in and look at it. All right, so how can you find the distance between 2 points? Oh yeah, and it's just like saying between point P and point Q. This is like nuts looking, right? But it's just saying P is x comma y, and we're just calling it x1 and y1. And Q is x2, y2. That's all we're looking at. So if I want to find the distance between these 2 points, let's talk about where distance comes from. So what I'm about to do, I'm doing once. I'm never going to ask you to do this. At least I don't think. It's not my plan right now, but maybe the book will be like, hey, you're supposed to ask them to do this. If we need to, don't worry, we'll talk about it together. So if I'm trying to find out how far apart they are, that's this side here. Look at that, it's a right triangle. Remember how a triangle you can say is a squared plus b squared equals c squared? If it's a right triangle, they call this Pythagorean Theorem, or Pythagoras' theorem. So, well, a squared, we could call this a if we want. A is from here to here, right? It's just your second x minus your first x, because it lines up with that point down there. So we just say it's your second x minus your first x, and then there was a squared outside. And likewise, we could say the side b, this, if I call this b, b is just from here to here. I could do y2 minus y1. So we'd say it's y2 minus y1 with a little squared because that squared was there. And that's equal to c squared. And if this hypotenuse here is c, well, then we could say that d is our distance, right? So we could say it's equal to the distance squared. And depending on how far your Algebra 1 teacher got last year, if you want to find out what d is, but it says d squared is here, what you can do is you can actually take the square root of both sides of the equation. On the left-hand side, it's a huge mess, so we're just leaving the square root the way that it is. But on the right side, the square root of something squared cancels out, and we're just left with whatever it is, just d. And so now we have this formula where it's just the one side of the triangle squared plus the other side of the triangle squared. Take the square root of it. If all of that was kind of over your head, don't worry. You will always have access to this formula. So they go through and they talk through everything. Wait, whatever. I talked out of order, I guess. Sorry, Sabas. All right, so let's talk about how the distance formula works. Here's a completely unrealistic example. A pitcher throws a ball to a batter who hits the ball to the shortstop. If the ball travels in a straight line between each, what is the total distance traveled by the ball? Round your answer to the nearest tenth of a foot. Okay, never mind. This is a pretty realistic example. This could be something that we want to find out. I don't know exactly why you'd want to find that out, but it might be interesting. So, a pitcher throws a ball to a batter. Throws a ball to a batter. Woo. I guess we're saying the batter is there, even though his hat is there, because that's where his mark is. So we want to find the total distance traveled by the ball. Well, it starts there. So let's find out how far apart those 2 points are. So we'll use the distance formula. It doesn't matter which one you start with. You can start with the pitcher or the batter. As long as you're consistent, it always works. So I'm going to set this up. I know I'm doing one side plus the other side squared. And the formula says x2 minus x1 and y2 minus y1. So I'm actually going to say pitcher to batter, just reminding myself. I'm going to call this PB. And let me see. Well, pitcher is at, what point is that? Looks like it's 5 over. And then 1, 2, 3, 4, 5 up. Okay, 5, 5. So I could do pitcher first. And if I do pitcher first in the first parentheses, I'll do pitcher first in the second parentheses. And then the formula has minus inside. And then batter, oh, batter's at 0, 0. So I'll put batter second, and then a little squared goes outside. So check this out. There's actually something really cool we can do. In our calculator, if you type in everything except for the big square root, don't type in the big square root yet, we can make it look like we did all this work by ourselves without our calculator. So I typed in 5 minus 0 squared plus 5 minus 0 squared, enter 50. I didn't actually do the square root. I didn't do the square root yet, so I'm going to leave the square root there, but I can write 50. Check it out. So whatever the square root of 50 is, that's how far it is from the pitcher to the batter. So let me check it out. Square root of 50, and this is why I didn't just, oh wait, let me go back. So square root is this blue check mark right here, right? So I need to push the second button to make my calculator think in blue, then I push it. Square root of 50 is yucky. It doesn't simplify nicely. So we will talk about simplifying radicals potentially. But for now, I'm going to say it's just square root of 50. All right. And then where does the batter hit it to? The batter hits it to, oh, it says round to the nearest tenth of a foot. Okay. But it says the batter hits the shortstop. Oh, first baseman's like, why am I here? So travels to the shortstop. So it went, all right, well, how far was the shortstop from the batter? Well, let's find out. We could say batter to shortstop. So if I'm trying to find the batter to the shortstop, we do the same kind of thing. It doesn't matter who you start with. Well, let me get the point for the shortstop. Shortstop looks like he's at 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5, comma 10. Okay. So you could start with the 5 and the 10. You could start with the 0 and the 0. It doesn't matter. So like if I start with the batter this time, I'd say 0 minus the shortstop is 5. You know, I'm using the x's first, squared, x2 minus x1, then plus y2 minus y1. So I'll say batter minus, so the batter's y was 0, shortstop's y was 10. And then again, we can go to our calculator and say, oh, here, if you're on a school calculator, you can actually just push up a bunch of times and it'll bring back stuff you've already typed in. So let's see, 0 minus 5, and then 0 minus 10. Oh, I have to do that, okay. 125, so this one equals the square root of 125. So for both of these, there's a way to simplify them, and that's an honors topic we will definitely cover in a separate video, but I'll come back to this. So let's see how they do it. So boom, boom, boom. Square root of 50 is about 7.1, and square root of 125 is 11.2, making the total 18.3 feet. Oh, what? The total distance is 18.3 units. A pitcher throws, oh, 1 unit equals 9 feet. Oh, I didn't see that. That's silly. Okay, let's talk about that. So we got 18.3 units, right? Well, if each unit is 9 feet, 18.3 spaces, we can do times 9, 164.7 feet. We just did times 9. Silly, silly. Okay. How far does the shortstop need to throw the ball to reach first base? So again, it's the same kind of thing. We're just going to do the distance formula. So a lot of times I like to skip writing it if I can. I'm doing shortstop to base, first base. So I do my x's first. Well, this x is 10. So I'm doing first base minus shortstop. Shortstop's x is 5. Throw the squared on it, plus Then I do the other, let's see, first base again. What's the y value? Oh, the y value is 0 minus, what's the y value here? Oh, 10. Throw a squared on it. And I got 125. And so I take the square root like we did before. It's 125. And then that's how many spaces it is. It's 11.18 spaces. And we're doing 9 feet per space, so they're about 100 feet apart. And it says round to the nearest tenth of a foot, so 100.6. All right. So that's basically it. We've got the midpoint, we've got the distance. So there's their little summary. Oh, let's check this out. What did Corey do wrong? He wants to find the midpoint, or she wants to, Corey could be either one, wants to find the midpoint of AB. You got these points. What's Corey's error? So we should take the x, so remember midpoint, we add up the x's divided by 2, add up the y's divided by 2. So we should take -3 and 1, right? Those are both of our x's. Oh, look at what Corey did. -3 plus 5. Looks like they mixed up and added up these two together instead of the x and the x and the y and the y. So they paired them up wrong. Oh, interesting. If M is the midpoint of PQ, what's PM and MQ? So let's think about this really quick. We've got some line segment, PQ. Here's M. It's the midpoint. Well, then that means bam, bam, right? Those two things are congruent. They have to be. So PM and MQ have to be congruent. But what about PM and PQ? PM and then the whole thing. Well, shouldn't PM be half as long as PQ? That's what it means to be a midpoint. Cuts it in half. And then let's see what the last one is. Is it possible for PQ to have two distinct midpoints that are different from each other? This is kind of a heady question, but could you have like an M and then a different M that was a different point but was also a midpoint? So if we're talking about a line segment, the problem is it needs to be on the line segment to be a midpoint. So even if I had a point like up here that was like bop and like this and this were the same length, this wouldn't be called the midpoint. This is just a point that is equidistant from both of those points. So this is not the midpoint. I can call it point N for not the midpoint. That's point M for is the midpoint. But I hope going through this has been helpful. Again, if you watch these and there's something I could be doing that would be more helpful, I'd love to know. I value your feedback. I hope this was helpful. All right, wow, I already said that, but that's like my sign off. I don't know. I don't really have a sign off. Maybe this is my